Hi, my name is Pedro Alcol, and I'm going to be talking about Zippex, which is an open source library that I built with a friend of mine, Pliny Smith. I work at Salesforce.org. That's my email. I'm a senior member of technical stuff. This is a utility that I built before I joined Salesforce, so this is not a Salesforce project. Everybody's aware of this. Just make purchase decision based on what is currently available. Okay, so first let's talk about why we care about zipping in Apex. So zip archives are very useful to group a bunch of files and keep the files, the directory structure, the folder structure. And it's great to attach them and send them on emails. But there's other things that you can do with zip files. So for example, Microsoft Word files are actually zip files. They just have a different extension. So if you're able to open zip files in Apex, you can actually edit Word files as well. And then another thing that you can do is called the full metadata API from Apex. There's now some limited support natively in Apex for the metadata API, but if you actually want to make a call to the regular metadata API, you need to actually zip files and send everything zipped, so you're able to do that. Some of you might recognize the icon there, the little deployment fish. So, all right. So, what are the challenges that we have in Apex? Well, to start, there's no zip support. So, we had to figure something else. So, we had to see if we could build it. But to build it, you need binary operations. Well, there's no binary operations in Apex. The only thing that you have is the blob class, and it doesn't have any support for editing the actual binary file. And then the next challenge is the governor limits. They're very strict because you're in a multi-tenant architecture, and you need to be able to execute very quickly. You can't do operations that are too expensive or you'll get terminated. So this is the documentation for the blob class. And as you can see, there are only 4 methods, and none of them let you edit anything inside a blob. So we figured out a way to do it, and the way was to actually convert everything into a hex string, and then use string operations on that, or if we needed to do math, we converted the hex into decimal, basically integers, did the operations there, and then work our way back. So for example, let's say we have the number 12 and it's binary data, so it's a byte, and you need to add 2 to it. The first thing that you do, you store it in a blob, then you convert it into hex. So now you have a hex string. This is not actual hex, this is actually this is ASCII. What you do then is convert the hex string into an integer. We store it into this variable. At this point, we're able to add 2. So we're going to get 14. And then we do the reverse operation. We convert the decimal into a hex string again, and then we can convert the hex string back into binary. So problem solved, sort of. This is very expensive because you have to do it a lot. So we had to figure out a way to improve or optimize the way that we're converting from ASCII to decimal and vice versa because of the governor limits. So at the beginning when we built this library, we were able to only do 4K files, which was not acceptable. So let me show you how we did it, and then I'll talk about some other options. So in this example, we have this hex string C, and we first converted it into a char, an integer, and then we do this weird equation here, and basically we're doing bitwise operations, so we're ANDing it with 15, and we're shifting to the right using unsigned shift right 6 times and then multiplying by 9. I'm not going to go into the details, but what happens is without any if statements or any conditionals, we're able to just convert immediately something from an ASCII value to the decimal that we need. So let's take a look at the zip file structure. Phil Katz created the zip format, and he actually open sourced the specification. He didn't open source the code, but luckily enough, we had the documentation, so we looked at that and figured out how zip file is structured, and that's how we built this library. So there are 3 types of headers in a zip library, in a zip archive, and those are the local header, the central directory header, and the end of the central directory. So let's take a look at each one of them really quickly. I'm not going to go into a lot of details, but this is the local header, and this is what precedes the actual file, the actual data for a file. And there are 3 things that are interesting here. So one is the signature, PK0304. That's how you locate that header, you know, where the header is in the file. PK stands for Phil Katz, who's the guy that created zip files. Then you have a CRC32, and that's a require field. It's used to do a check after you get the file back. And then you have the file name. So let's look at the next header, and that's the central directory header. And again, it's very similar, but this one is not used to precede the file. This one is used to show a list of all the files in the zip archive. So again, signature, slightly different, CRC, and file name. One big difference is on the yellow box, there's an offset to the local header. So once you find this, you can locate where the file is by looking at that offset of the local header. The last header that we're going to look at is the end of the central directory. So this one is to close the file, and it basically tells you things about the zip archive, like the number of disk entries and also the offset to the central directory. Again, you have another signature. So let's take a look at how we would parse a zip file that already has files in it. So the first thing that you do is you do a string search in this case, because we're dealing with hex strings, and we look for PK0506. So we look from the end back, and that is when we find the central directory. We parse the central directory, and that gives us a pointer to the beginning of the central. We parse the end of the central directory, and it gives us a pointer to the beginning of the central directory headers. In there, you have headers for each one of the files, so you can look at the file structure. You parse all those, and then if you need to grab one file, so in this case, let's look at file 2. So first we parse the central directory header for file 1, points to file 1. Then there's the next one, that is file 2. That's the one that we want, and it gives us a pointer to the local file header 2. We would parse that, and it'll give us the information that we need to extract the data that is immediately after that. So let's look at some operations and see how they're performed. So in this case, I have a zip archive that already has a couple of files, and I want to add another one. So in memory, I have the same structure, basically, and I want to add one more file. After I do that, the next thing that we do is we kill the central directory and the end of the central directory. We delete it, and then we will recalculate it. We do this because there's going to be different offsets, so it's just easier to recalculate it. So it goes away. We add the file, and then we recalculate all the central directory files and the end of the central directory with the correct offsets. All right, let's take a look at the syntax of the library. So it's very simple. I'm just going to go through some examples. So let's say we want to add a file. to a zip archive that it's empty. So the first thing that we do, we instantiate the Zippex library, and then we need some data. So in this case, I just created some sample text, and I'm going to convert it into a blob and store it in this blob variable. Then we call the add file method, and it takes 3 parameters. The first one is the file name. You can include the folder there, and so full path if you want. And then file data is the next one. That's a blob. And the third item is a CRC32. If you pass a null, the library will calculate it for you. However, it's a very expensive operation, so if you want to pre-calculate them ahead of time and then pass it yourself, then it saves a lot of time. So you could do future calls if you want to calculate a CRC, and then when you pass it here, you save a lot of time. All right, so let's add another file because I want to show you how to delete it. So in this case, I add file2.txt. And then we're going to remove the file. Very simple, just one parameter, just pass the file name, including the full path. All right, if you want to rename a file, again, all file name, new file name, let's rename. And then to actually get the zip archive, so basically right now in memory, this is all a hex string, so you want to get it as a blob, and you want to calculate the directory, the central directory. You just call the getZipArchive method, and that gives you a zip file. So let's take a look at how to work with a file that already, or a zip archive that already has files in it. So what you do is you call this other constructor, the one that accepts a parameter, and the parameter is a blob with a valid zip archive. The next thing is to get the directory. So you call the getFileNames method, and that is going to return an array of strings. And each one of those strings is the file name of each of those files. So let's say in this case we want to grab file 2. We call the getFile method, and that returns a blob. And that's the binary information inside that file. In this case, it's a text file, so you can just convert it into a string directly. All right. I'd like to open it up for questions, and I want to remind you to open the app and make sure you give some feedback. Okay. What's that? Largest file, zip file you can handle. That's a hard question to answer. So it depends if you're adding things to a file or if you're unzipping. Unzipping is much more expensive. So if you're adding files and you pre-calculated the CRC, I think you can go to 1 meg, maybe 2. So you have to worry about CPU limits, and then you also have to worry about heap size. So anytime you have any files that you're adding, you have a variable with that file, and then when you send it to the zip utility, there's several variables that will duplicate or triplicate that file. So it gets a little tricky. But you can do your own test and try zipping and unzipping things and see where you get. Okay.
Supports gzip like Google Zip?
Gzip, I'm not sure. So is it regular zip files, or you mean it's just the raw compression? The raw format, not directly, but look at it's open source, so look at the code. You might be able to update it and be able to use it that way. So, any more questions? All right, well, thank you very much.